For question number 7, we're given that a car has mass 1. Sorry. Question number 7 is a car has mass 1200 kg. When the car is traveling at a speed of meters per second, there is the resistive force of magnitude K times V newtons. The maximum power of the car's engine is 92.16 kilowatts. For part A, the car travels along a straight level road, and part I of part A, first part, the car has a greatest possible constant speed of 48 meters per second. Show that K is equals to 40. So let's draw a diagram first. This is the straight level road. This is the car. It has a mass of 1200 kg, so that means it has a weight of 12,000. This is R. They have given us the maximum power of the car, which is 92.16 kilowatts, and that means that is 92,160 watts. And we know that the power is equals to the driving force times velocity. Now they've given us the power 92.160 and they've given us the speed. That means we can find out the driving force. So 92,160 is equals to the driving force times 48, and dividing 48 on both sides, we get the driving force to be equals to 1920. So we have a force of 1920 moving it forwards. A is an arbitrary constant given to us, meaning that it is a fixed constant which we don't know yet, and it is for friction, which is the resistive force. So we can incorporate it into the forces formula, which is forward force minus resistive force is equal to the mass multiplied by the acceleration. Forward force is equals to the driving force, since it is moving it forward, moving at a constant speed, meaning that the change in speed or acceleration is 0 as well. So this entire side becomes 0, making the forward force equals to the resistive force, which is friction. So that means that the driving force 1920 is equals to the friction. The formula for the resistive force is equals to K, which is an arbitrary constant, and V, which is the velocity at which the car is operating. So 1920, which is friction, must be equals to K times the speed, which is 48. That means K is equals to 1920 divided by 48, which is equals to 40. Part 2. At an instant when its speed is 45 meters per second, find the greatest possible acceleration of the car. We're given the speed, which we can put in the friction formula, and friction formula was equals to K, which we found out as 40, and times V, which is the velocity the car is operating, which is 45, and 40 times 45 is equals to 800. So we have the value of friction. Other than that, we are given that the maximum possible power of the car is 92,160, and we can incorporate it into the power formula again, which is power is equals to the driving force multiplied by V. Now we have the V in this case, which is 45. We can use that again. So driving force multiplied by 45, dividing 45 on both sides, we find out the driving force is equals to 2048. Now we can use these two facts again and incorporate it into the forces formula, which was forward force minus resistive force is equal to the mass multiplied by the acceleration. So the forward force is equal to the driving force again, which is 2048, and the resistive force is the friction, which is 1800, minus 1800 is equal to the mass, which was 1200, times acceleration. So 2048 minus 1800 is 248, and this is 1200 A, meaning that the maximum possible acceleration is 248 divided by 1200. For part B, for question number 7, we say that the car travels at a constant speed up a hill inclined at an angle of sine inverse 0.15 to the horizontal. Find the greatest possible speed of the car going up the hill. So first let's write down what we already know. So we know that the greatest power of the car is equals to 92,160 watts, and that the mass of the car is 1200, and we also know that the friction is equals to 40 multiplied by the velocity of the car. They've also given us the angle of the hill. So first let's draw the hill. Let's say this is a hill. So now I will substitute value such as theta in place of sine inverse 0.15 to make it easier. So let's say this is theta, this is the car, and now the weight will have two components. The angle inside will also be theta, and the downward component of the weight will be equal to 1200 the mass multiplied by the force of gravity, which is 10. So this will become 12,000 cos theta, and this will become 12,000 sin theta. There is a r, which is the normal reaction. Then since the car is moving upwards, this will be the driving force pulling it upwards, and since friction operates the opposite direction of movement, the friction will operate backwards. So now let's use this power given to us and find out the value of the driving force. So power, which is 92,160, is equals to the driving force multiplied by the velocity. Now both driving force and velocity are unknown, so in order to write it in terms of driving force, we'll divide V on both sides, making 92,160 equal divide by 92,160 divided by V equals to the driving force. Use this driving force in the forces formula again. So forward force minus resistive force is equal to the mass multiplied by the acceleration, and they've told us that the car is moving up at a constant speed again, so that means acceleration is equals to 0, making the right side of the equation also equal to 0. So that means that forward force must be equal to the resistive force acting on the car. So in this case, the forward force is equal to the driving force, which is 92,160 divided by V, which we took from over here, and the resistive force will be the force of friction, which will be 40V, as well as this 12,000 sine theta, which is pulling the car downwards along with the force of friction. That is 12,000 sine theta. Now we said that sine theta was equals to sine inverse 0.15, so we can substitute that here. So 92,160 divided by V, and we can take this 40V to the other side in order to put like terms together. Minus 40V is equals to 12,000.15. So this side, the right side, is equals to 1800, and this side remain the same. So what we can do is that we can multiply V on both sides in order to cancel this V in the denominator. So this will become 92,160 minus 40V squared is equals to 1800V. 40V squared minus 40V squared plus 1800V minus 92,160 is equals to 0. Now we can apply the quadratic formula on this, and we will find that V is equals to 30.5, which is the greatest speed of the car going up the hill.